Okay, so today we are going to see about polar coordinates, where we'll be studying the system of a particle at the point P in two-dimensional systems. Usually, we use the Cartesian coordinate system for representing an object in three-dimensional space. In order to represent an object in two-dimensional space, we use this polar coordinate system. Okay. For this, we can consider a particle which is P, and the particle P is at the distance of small r from the center O, and we have two axes of x, y, where the particle P makes a distance of small x from the point O, and the particle P is at the distance of small y along the y-axis. So this particle P can be represented as r comma theta, where theta is actually the angle swept from the x-axis. Here we will be calculating the position, velocity, and acceleration of the particle in polar coordinates. Before moving into the position, velocity, and acceleration, let us find the values of r, theta, and the unit vectors for this particle P. First, we are going to find the relation between x comma y and r comma theta. Why we are going to find this relation between x comma y and r comma theta? Because we have to find the values of r and theta. Since this small x is along the x-axis, we can just write that x is equal to r into cos theta and y is equal to r into sin theta. In order to find the value of r, we can just square the two terms of x and y, where we get x square is equal to r square cos square theta and y square is equal to r square sin square theta. Now we can just add x square plus y square, which is equal to r square cos square theta plus r square sin square theta. Now we'll take this r square common. We'll get cos square theta plus sin square theta. So we know that cos square theta and sin square theta is equal to 1. We'll get that x square plus y square is equal to r square, or we can write r is equal to square root of x square plus y square. So now we have calculated the value of small r. Now we have to find the value of theta. To find the value of theta, we can write as y by x, which is equal to sin theta by r into cos theta. So here r and r gets cancelled. So what we'll get, y by x is equal to tan theta, which implies that theta is equal to tan inverse of y by x. So now we have found the values of r and theta. So before moving to the position coordinates, we have to find the values of each unit vector which is acting on this particle P on point P. Now, in order to write the equation for position, velocity, and acceleration, first we have to find the values of a unit vector. So we know that A unit vector is nothing but a vector having a magnitude of 1, where we are going to consider only the direction. Here, let I vector be the unit vector along the x-axis, and small j vector be the unit vector along y-axis. And also we are considering another unit vector, which is theta cap, along the angle of theta. And here this line is nothing but r vector, where the unit vector here along the radius is nothing but r cap. So first we will write the equation for r cap, where r cap is equal to cos theta I cap plus sin theta into j cap. And similarly, theta cap is equal to, we'll be considering the negative side of I cap, so that will be minus of sin theta I cap plus cos theta j cap. We have to know that the r cap is nothing but the unit vector along the direction of the increasing value of r, and the theta is the unit vector along the direction of increasing value of theta. And also we know that r cap is perpendicular to theta cap. So now we have found the values of r cap and theta cap. By using this, we will calculate the position vector. The position vector, we can write the radial distance as r vector is equal to r into r cap. We can just expand this equation, where we know that r cap is nothing but cos theta I cap plus sin theta j cap. We have just substituted the value of r cap. Now we can just multiply this r inside, so we'll get r into cos theta I cap plus r into sin theta j cap. This is nothing but r vector. We know that r cos theta is nothing but x, and r sin theta is nothing but y. Finally, r vector is equal to x into I cap plus y into j cap. Now, since we have calculated the position vector, we can use that value of r vector to calculate velocity. We know that velocity is nothing but rate of change of displacement. Here, the velocity is represented as v vector, which is equal to d by dt of r vector. Now, we will just substitute the value of r vector in this equation, where d by dt of r vector is nothing but r into r cap. Now we'll just differentiate this, where we will get dr by dt into r cap plus r into d r cap divided by dt. This can be written as v vector is equal to d by dt is nothing but r dot and r cap plus r into d r cap divided by dt. Here we have known the value of r cap, but we have to calculate the value of d by dt of r cap. Let's calculate. So r cap is nothing but cos theta I cap plus sin theta j cap. So this is a known value. So by using this, we will calculate d by dt of r cap, where d by dt of r cap is equal to minus of theta dot into sine theta I cap plus theta dot cos theta j cap. Just take this theta dot common, so we'll get minus of sine theta I cap plus cos theta j cap. Now we can replace this whole term as theta cap, because this whole term is nothing but the unit vector along the value of theta. We can write that dr cap by dt is nothing but theta dot into theta cap. We'll just substitute this value in equation A, that is velocity. We'll get v vector is equal to r dot into r cap plus r into, instead of d by dt of r cap, we can write as theta dot into theta cap. This is the equation for velocity on a polar coordinate. So by using this velocity on a polar coordinate, let's calculate the acceleration due to this polar coordinate. In order to calculate the acceleration, that is small a vector, we know that the velocity v vector is equal to r dot r cap plus r into theta dot theta cap. A is nothing but d into v vector divided by dt. We'll just substitute this on equation, so we'll get d by dt of, instead of v vector, it is r dot r cap plus r into theta dot and theta cap. R double dot and r cap plus r dot into d r cap by dt. So this is for the first term. So next calculate the second term. So plus r dot theta cap plus r into theta double dot theta cap plus r into theta dot into d theta cap divided by dt. In this equation, we know that the values of dr cap by dt is nothing but theta dot theta cap, but we don't know the value of d theta cap divided by dt. So for that, we will be calculating the value of d theta cap by dt by using the value of theta cap, where we know that theta cap is equal to minus of sine theta I cap plus cos theta j cap d theta cap divided by dt is equal to minus of theta cap cos theta I cap minus theta dot sin theta j cap. If we take minus theta dot common, we'll get cos theta I cap plus sin theta j cap. So now this term cos theta I cap plus sin theta j cap is nothing but r cap. So we can write this equation as minus theta dot into r cap. So d theta cap divided by dt is equal to minus theta dot into r cap. So let's substitute this value in acceleration a vector, which is equal to r double dot r cap plus r dot theta cap plus r dot theta cap plus r into theta double dot theta cap minus theta dot r cap into r theta dot. We can write this equation as a vector is equal to r cap r double dot minus r theta dot square plus r into theta double dot plus 2 r dot theta dot into theta. We just grouped the similar terms and we just wrote the final equation of A, that is acceleration. This is the equation for acceleration on a polar coordinate system.